You should have received an invite code in email from Slim. Enter the invite code as shown here. You can use any of the OAuth providers in the list, GitHub, GitLab, or Bitbucket, to sign in to the Slim developer platform. I'll use GitLab. Since I had logged in previously, I wasn't asked to authenticate using my GitLab credentials. If this is your first time logging in, please authenticate using the provider's login forms. Once the login is successful, it will bring you to the Slim developer platform homepage. The Slim developer platform allows you to explore, analyze, and understand Docker containers simply and easily. The main search bar on the homepage allows you to enter text search strings, account repository tag references, or pull commands to find containers of interest. You can think of it as Google search for containers. The Slim developer platform currently searches both Docker Hub and Red Hat public registries. The section below the search bar contains a set of tiles that represent container collections. These collections provide lists of popular containers organized by category. Slim provides a default set of collections for your convenience. You can also create your own collections. I'll show you how to do that later. Let's explore the popular Docker Hub collection. The number on the tile indicates the total number of containers listed in that collection. This collection contains a list of some of the most popular container images found on Docker Hub. To use the search interface, start by typing a search string into the search bar. I will search for a container using the search term Nux. Search results are a list of containers that satisfy the search criteria. These containers are sourced from both Docker Hub and Red Hat public registries. Click the Version Settings drop-down to see the various versions that are available for the first container in the list. I'll select the latest version for further analysis. When I click this version or anywhere in the search results tile for this container, I will trigger the analysis. Depending upon the composition of the container being analyzed, analysis can take up to a few minutes to complete. When the analysis is complete, you are presented with the analysis results. The analysis results page heading shows the name and tag for the container that was analyzed. It also shows the name of the registry where the container was found, when the container was last updated, and the total number of downloads and stars recorded in the registry. The main results of the analysis are organized under three main tabs labeled Overview, Explorer, and Dockerfile. The Overview tab has several sections. The first section contains basic properties of the image, including the maintainer name, scan details, and fundamental information about the container composition, including base operating system, open ports, and uncompressed container size. Pull by tag and pull by digest strings are also available. You can use the copy link to this image button to acquire a link to these analysis results. This is a convenient way to share a detailed report about a container of interest with a colleague. The Environment Variables section lists environment variables that were detected during analysis. Environment variables provide useful information to help understand major packages included in the container. We can see that this container includes node.js and the Yarn package manager. Other sections of the report include listings of any mounted volumes, available versions listed in the container registry, and any written description provided by the author that was available on Docker Hub. The Explorer tab provides several views of the internal container composition at a very detailed level. This view allows a developer to deeply understand how a container is built, the structure of its layers, the files contained within, and the instructions that produce the container in a very simple and easy way. File Explorer allows you to expand each layer of the container and observe the files contained in that layer. You can click on any listing in the expanded File Explorer to see details about a file in the right pane of the file viewer. Layer Explorer shows each layer in the container and expands to reveal the Docker file commands that produced each layer. Instruction Explorer lists all of the Docker instructions that were run to compose the container. Expanding each node in the instruction list reveals which layer was impacted by that instruction. JSON Explorer shows the raw analytic output from the container analysis. The search bar allows you to enter a text string to search for specific details in the JSON listing. Track Explorer provides a graphical representation of a container starting with the images and instructions on the left and the relationships between those layers and the files contained in each layer. This view is an easy way to get a general overview of the container and all of its components. The Docker File tab contains a Docker file that the Slim developer platform generated by analyzing the composition of the container. It does not represent the original Docker file that created the container image initially, but it is a close approximation. The Docker file viewer allows you to search and browse the Docker file in a code editor style interface. Let's return to the Overview tab to create a new collection and add this container to the collection. To do that, click the Add to Collection button. Click Add New Collection, enter a collection name, and click the Save Collection button. Click the checkbox near the name of the collection you just created and close the dialog. Return to the home page by clicking the Slim.AI logo in the upper left-hand corner of the page. Click the Your Collections pill button. You can see the tile for the test collection. Click the tile. The collection lists the container we analyzed. Success!